morning, ma'am. Good morning, classmates. I am Mary Jolly Subiera, and I am part of the Group 1, and we are going to tackle all about the activity number 7, which is the preparation and standardization of 0.1N potassium permanganate. For the objectives, here is Miss Frenal.
Our objective for this activity is, at the end of this activity, the students are able to prepare and standardize the prepared potassium permanganate, compute the concentration in normality of the prepared potassium permanganate, provide answers to the following questions to understand the concept of this experiment. The materials and reagents involved are about 3.3 grams of potassium permanganate, about 1 grams of the reagent sodium oxalate, distilled water, hot plate with wire gauze, titration set, and 200 ml Erlenmeyer flask and stirring rod.
Procedures. Preparation: first, to dissolve about 3.3 grams of potassium permanganate in 1000 ml of water in a flask, then boil the solution for about 15 minutes and insert the stopper in the flask after. Then allow it to stand for at least 2 days and filter through asbestos. For standardization, first, weigh accurately about 200 milligrams of sodium oxalate, previously dried at 110 degrees Celsius to constant weight, and dissolve it in 250 ml of water. Then add 7 ml of sulfuric acid, heat to about 70 degrees Celsius. Then slowly add the potassium permanganate solution from a burette with constant stirring until a pale pink color, which persists for about 15 seconds. Note that the temperature of the conclusion of the titration should not be less than 60 degrees Celsius. Lastly, calculate the normality.
So, moving on to the chemical reaction involved in this activity. It is 5 sodium oxalate plus 2 potassium permanganate plus 8 sulfuric acid, and it produces a product of 2 carbon dioxide plus 2 sodium sulfate plus manganese sulfate plus 10 carbon dioxide and 8 water. So that's the chemical reaction involved. Moving on to the data presentation, here is Ms. Escanio.
Let us go now to the data presentation. So these are the data that were obtained at the given activity. So we have 2 trials, the trial 1 and trial 2. For the weight of sodium oxalate in grams, the trial 1 has obtained 0.2202 grams, while the trial 2 has obtained 0.2230 grams. In the final reading of potassium permanganate in milligrams, 32.2 ml in trial 1 and 31.3 ml in trial number 2. For the initial reading of potassium permanganate in ml, both trial 1 and trial 2 has 0 ml. So next is the volume of potassium permanganate used also in ml. So for the trial 1, we have 32.2 ml, the same as true with the final reading of potassium permanganate in ml. So in the trial number 2, we also have 31.3 ml, the same also with final reading of KMnO4 ml. So for the volume used of H2SO4 used in ml, we have 7 ml for both trial 1 and trial 2. And for the normality, the trial 1 has 0.051 normality and 0.053 normality for trial 2. And for the average normality of both trial 1 and trial 2, the result shows that this has obtained 0.052 normality. So if you're wondering where did the answers came from, this will be further explained by the next reporter. Thank you.
For the normality. Madali lang yung pagkuha ng normality if you know the formula. I am using 2 formulas, pero yung ginamit namin for this activity is yung hindi complicated, which is normality is equal to weight of the sample over volume times the milli-equivalent na na-derive siya dito na formula. Since kailangan yung milli-equivalent weight, yung formula naman para dito is milli-equivalent weight is equal to molecular weight over 1,000. The first step sa pag-calculate na ng normality is yung kukunin mo muna yung molecular weight ng sodium oxalate, which is 134 grams per mole. The next one is yung, since nakuha mo na yung molecular weight, isosolve mo na yung milli-equivalent. So, 134 over 1,000 is 0.134. The next one is i-distribute mo na yung given or i-substitute mo na siya doon sa formula. So, for example, sa trial number 1, yung normality is equal to 0.2202 grams since yun yung weight ng sample over 32.2 ml of potassium permanganate times the 0.134. So the answer is 0.051 normality. The same goes with the trial number 2. Then after that, i-solve mo na yung average normality. The formula for this is i-add mo lang yung yung answer ng trial number 1 sa trial number 2, then i-divide mo yun siya sa 2. And the average normality would be 0.052 normality. And that would be all for the calculation of normality.
Data interpretation. In the data presentation, the weight of sodium oxalate in grams in trial number 1 is 0.2202 grams and the trial number 2 is 0.2230 grams. The final reading of potassium permanganate in milliliters of trial number 1 is 32.2 milliliters and the trial number 2 is 31.3 milliliters. The volume of potassium permanganate used in trial number 1 is 32.2 milliliters and the trial number 2 is 31.3 milliliters. The volume of sulfuric acid used in trial number 1 is 0.051 N and the trial number 2 is 0.053 N and the average normality is 0.052 normality. Conclusion. Therefore, in the preparation and standardization of 0.1 N potassium permanganate is important in order to know the presence of normality of a substances, and it is useful as indicator in a titration process and it has a low-cost value in the market. Thus, the solution of chemical reaction are determined to be used as reagents in other set of laboratory experimentation. Learning questions. Number 1. Define the following terms. First is oxidation. Oxidation is the process of losing electrons in a chemical reactions or being oxidized. Letter B. Reducing agent. Reducing agent is a substance which loses electrons to other substances in a redox reaction and gets oxidized to the higher valency state. Lastly, the equivalent weight of the oxidizing agent is the weight which gains electrons equivalent to 1 Faraday or to the electrons gained by 1 gram ion of hydrogen ions 2H plus 2E plus H2. Learning question number 2. Refer to the USP and give the formula and equivalent weight of the primary standard used in standardizing. In letter A, 0.1 N iodine, so I2 plus 2A, it reacts iodine reacted to iodine ion, and the equivalent one is equals to 1 equivalent is equals to 253.80, which is the molecular weight of iodine, divided by 2, which is equivalent or equal to iodine ions factor, is equals to 126.9 grams. In letter B, the 0.1 N potassium permanganate plus 5E plus Mn2 means that the potassium permanganate reacted to manganese ion, and the equivalent weight is equals to 1 equivalent is equals to 158.03, which is the molecular weight of potassium permanganate, divided by 5, which is the factor of manganese ion, is equals to 31.61 grams. And lastly, letter C, which is the 0.1 N ceric sulfate, Ce4 plus E is equals to ceric ion reacted to serous ion. Equivalent weight is equals to 1 equivalent is equals to 332.24, which is the molecular weight of ceric ion, divided by 1, which is the factor of serous ion, is equals to 332.24 grams.
Learning question number 3. 0.2295 grams of sample of sodium oxalate, or the 97.8% of sodium oxalate, required 35.12 ml of potassium permanganate solution in a titration. What was the normality of the permanganate solution? In order to get the normality of permanganate solution, the first thing we need to do is to get the weight concentration by using the formula percent concentration is equal to ml times n times milli equivalent weight over sample weight in grams times 100. And then by using the formula of normality, which is n is equals to weight concentration times sample weight in grams over ml and milli equivalent weight times 100. N is equals to 97.8 times 0.2295 grams over 35.12 ml of potassium permanganate times to 0.067 times 100. And the answer is 0.0954. So the normality of the permanganate solution is equal to 0.0954 N.